Today we're going to be talking about solving trigonometric equations. An equation that contains trigonometric functions is called a trigonometric equation. Remember that when we are dealing with equations, we are solving for values of the unknown that make the equation correct. For example, sine squared x plus cosine squared x equals 1 is an equation, but we also saw that this relationship is an identity, and that means that the equation holds true no matter what number you plug in for x. Hence, the solution to this equation is all real numbers. But how about tangent of 2x minus 1 equals 0? That is the goal of this section, to find the values of x, if any, in which this equation holds true and other equations like it. Keep in mind, since that the trigonometric functions are periodic, if we have a solution, we have infinitely many solutions. So we first find the solutions in one period, then find the rest of the solutions. In this section, we see how algebra, inverse trig functions, and identities come together in helping us to solve trig equations. Let's learn different methods in the following examples. So we have a picture of a unit circle here, and what this is depicting is that there are two different locations on the unit circle where the sine value of the angle is equal to 1/2. And the place that happens is sine of pi over 6 is equal to 1/2, and sine of 5 pi over 6 is equal to 1/2. But that's only if we are talking about between 0 and 2 pi, but here beneath that we have our periodic function sine that I'm highlighting right now, and we know that the domain is all real numbers, so this goes on forever and ever and ever, and then we have this horizontal line here that represents 1/2, and so all of these intersections represent solutions to our equation. And so the way that we are going to represent our answers is basically in example 1, it asks us to solve for sine of theta is equal to 1/2. Now what you could do is you could apply sine inverse or arc sine to both sides of this equation. And the left-hand side of the equation will become theta, since those are inverse functions of each other. When we compose them like that, it just leaves us with theta. And then we have sine inverse of 1/2. Now, this is where we have to be a bit careful, because remember that when we defined the inverse function y equals sine inverse of x, we said that the range of this thing was the values between negative pi over 2 and positive pi over 2. So if you were to plug this thing into your calculator, what your calculator is going to spit out is pi over 6. So I've pulled up my calculator, and I'm going to go ahead and put it into radians. Now I'm going to do arc sine of 1/2, and it gives me 0.5235, etc. And if I did this correctly, that should be pi over 6, which it does, it matches up. However, the downfall of plugging this into your calculator is that there are two places on the unit circle where this is happening. So the one place we identified was here at pi over 6, but at 5 pi over 6 we have a sine value of 1/2 as well. And so that's something that we have to be mindful of as we're seeking solutions for this equation. So one of our solutions is pi over 6, and another one that we have, if we're thinking about our unit circle, is 5 pi over 6. However, we also need to think about all of the coterminal angles that are coterminal to these two angles. And so the way that we account for those is we have plus 2 pi k, where k is some integer for both of these. Notice here that it says plus 2 pi n. N is also an integer or a whole number in those scenarios. You can use whatever variable you would like as long as you are indicating that k is an integer. So this here, what I'm boxing now, represents our final answer for the equation sine of theta is equal to 1/2. Those are all the angles that are a solution to that equation. All right, so the next example we want to solve says cosine of x is equal to 0.72. So I, for these questions, very much like to draw a quick sketch of my unit circle, and we have a cosine value that is positive, and there is a mnemonic device that says all students take calculus, and this mnemonic device tells us where each trig function is positive. So all of them are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in tangent 4. What this tells us is that when we are seeking out solutions, because 0.72 is a positive number, there's going to be, I'm going to redraw this circle so that it looks a little bit nicer. Okay, so there's going to be some angle in quadrant 1 so that this terminal point here is 0.72, comma, something. I'm just going to put question mark. We don't really care what that y coordinate is. We just care that the x coordinate is 0.72 since x corresponds to cosine. And then there is also some angle in quadrant 4 where the x coordinate is 0.72 as well, and then this is going to be negative question mark. Whatever question mark is, again, we don't really care about what the question mark is. And so what we're going to do is, in order to solve this equation, we have cosine of x is equal to 0.72. I'm going to take cosine inverse of both sides so that I can throw that into my calculator, and the left-hand side of the equation will be x, and then on the right side of the equation, I'm going to throw cosine inverse of 0.72 into my calculator and press enter, and we get 0.766. I'm just going to round that to 2 decimal places, so 0.77. So what that tells us, and remember our x value is an angle in radians, so what that tells us is this angle measure here is 0.77. Now, how do we go about figuring out the other angle? Well, if you are just going in the negative direction, which nothing says that we can't, because sometimes they'll specify that you want positive angles, but if we want to get this angle, we could just go in the other direction and go negative 0.77. So I'm going to do that in this example. Again, there are other examples where it only asks for positive angles or angles between 0 and 2 pi, but there's no restriction like that here. So I'm going to say x is equal to 0.77 and x is equal to negative 0.77, but then we also need to include all of the coterminal angles. So I'm going to plus 2 pi k, where indicating k is an integer, and plus 2 pi k, where k is an integer for this one as well. So these are my answers for part B.